The range of a matrix, which is sometimes referred to as the column space, has some particular results we'll key in on here, and then we'll work through an example of describing the range. The reality is here, though, that it will work the same way as the span. It's just that now we're talking about a matrix, and the columns of that matrix represent the vectors that we would have been investigating when we were talking about the span of a set of vectors. So the results here that the range of A is denoted by R of A, and we can also discuss R of A as the set of all Y values such that those vectors Y are the outputs from products of A times X. And that would be for some X in Rn. And we also have just a written out description here that says that the range of A is the set of all vectors Y in Rm such that A times X equals Y is consistent. So these are just some results that we have and some things that we want to be generally aware of in terms of how we describe the range. As an example of that description, again, we'll think just like we did with span. We'll take a matrix A, 1, 2, 1, minus 2, minus 3, 0, 1, 5, 7. And again, we can think of each one of these columns as its own vector. So realistically, we're talking about the same thing as the span of these column vectors, which is why we call it the column space sometimes. So now it's just in this matrix for us already, and we want the outputs to take a particular form. For some reason or another, the author chooses to use B here instead of outputs Y. So we'll take the vector B to be all the values in our range. Then we can find the range by simply throwing all of this into an augmented matrix. And doing our row ref process. So again, this is really the same exact process that we would have done when we were finding the span. So go ahead and do that row reduction process. And just like we had with span, we're going to look for a consistent relationship across the bottom. And you can check that below to see that you've got the correct relationship.